Hello students, today we will see different types of active sensors. First, we will start with the laser scanner. What is the full form of laser? We know the full form of laser. The full form of laser is light amplification by stimulated emission and radiation. Laser scanners are mounted on aircraft and use a laser beam, that is basically the infrared light, to measure the distance from the aircraft to point located on the ground. This distance measurement is then combined with exact information on the aircraft's position to calculate the terrain elevation. Laser scanning is mainly used to produce detailed high resolution digital terrain models. The short form is very popular, that is called the DTM, for topographic mapping is used using this laser scanner. Laser scanning is increasingly used for other purposes also, such as the production of detailed 3D models of city buildings and for measuring tree heights in forestry, etc. etc. We'll go to the next, that is the radar altimeter. What is this radar altimeter? The full form of radar is radio detection and ranging. Radar altimeters are used to measure the topographic profile parallel to the satellite orbit. They provide profiles, single lines of measurements rather than imaging data. Radar altimeters operate in the 1 to 6 centimeter domain and are able to determine height with a precision of 2 to 4 centimeter. Radar altimeters are useful for measuring relatively smooth surfaces such as oceans and for small scale mapping of basically continental terrain models. So there are several applications of radar altimeter. Next, we will see the imaging radar. Imaging radar is basically another technique. So radar instruments operate in the 1 to 100 centimeter domain. As in multispectral scanning, different wavelength bands are related to particular characteristics of the Earth's surface. The radar backscatter is influenced by the illuminating signal, that is microparameters, and the illuminated surface characteristics are different characteristics are there: orientation, roughness, dielectric constant, moisture content. Since radar is an active sensor system and applied wavelengths are able to penetrate clouds, it has all weather day and night acquisition capability. So imaging radar is very important. That is, in case of SAR measurement, surface acquisition measurement, we can implement this imaging radar system. Next, we will discuss different platforms in case of remote sensing. So in remote sensing, the sensor is mounted on a platform. Obviously, if you want to use the sensor, you have to mount the sensor. In general, remote sensors are attached to the moving platforms such as aircraft and satellites. These are the two popular mechanism or mounting mechanism in case of remote sensing. First, we will see the airborne remote sensing. The figures are given depending upon the roll angle, pitch angle, yaw angle. We are classifying the airborne remote sensing. Airborne remote sensing is basically carried using different types of aircraft depending on the operational requirements and budget available. Next point we will see, that is called the spaceborne remote sensing. Spaceborne remote sensing is carried out using sensors that are mounted on satellites. Obviously, the monitoring capabilities of the sensor are to a large extent determined by the parameters of the satellite's orbit. Different types of orbits are required to achieve continuous monitoring metrology. They have talked about in this particular model, they have talked about the altitude, inclination angle, period, repeat cycle, different parameters are there related to the spaceborne remote sensing. That's all for today. Next class, we will see another topic, new topic related to the remote sensing mechanism. Thank you.